All right, welcome to lesson 107, area of complex shapes. This will be a quick and simple lesson, so I hope you're ready for it. But as always, we're going to start with our mental math, so make sure you're with me on page 557. Let's just jump right in and remember to pause if you ever need extra time. Okay, so for letter A, we're going to start with 100 times 100. What is 100 times 100? The answer is 10,000. Letter B, 376 minus 150. What is 376 minus 150? The answer is 226. Letter C, 10% of 200. What is 10% of 200? The answer is 20. Letter D, $12.89 plus $9.99. What is $12.89 plus $9.99? The answer to that is $22.88. Letter E, 6.0, or just 6, divided by 100. What is 6 divided by 100? The answer to that is 6 hundredths, or 0.06. Remember, that one's moving the decimal over. Letter F, what is 360 divided by 60? 360 divided by 60. The answer to that is 6. Letter G, how many pints are in a gallon? How many pints are in a gallon? The answer to that is 8 pints. Then letter H, the calculation. We have 10 times 6 plus 4. Take the square root times 3 plus 1. Take the square root times 7 plus 1, and take the square root of that, and your final answer should be 6. All right, so good job on that warm-up, and like I said, let's just jump right into area of complex shapes. So hopefully you remember lesson 103, we found perimeter of complex shapes. So remember, perimeter is the distance around, area is sort of the amount of space it takes up. So we're going to find the area of these complex shapes. And we're going to really look at one example, and then 2 examples in your practice set. So make sure you're paying good attention, taking notes. If you have any questions on this, please let me know. So let's look at this first figure here. So some of these dimensions are given to us, and some of them are not. So one of the first things we can do is use what we learned from that previous lesson to find the length of the figures, the sides that we don't know the lengths of. So let's look at letter A, for example. We know that, or we can tell that length A plus 4 is going to equal 6. All right, those are all those parallel lines that are part of this complex figure. So if A plus 4 equals 6 centimeters, then A must equal 2 centimeters. So I'm just going to erase that and fill in 2 centimeters. And then for B, we can see that length B plus 3 centimeters will equal 7 centimeters. So B plus 3 equals 7. Then we can find out that B equals 4 centimeters. Okay, so remember we learned all that back when we were talking about the perimeters of complex shapes. Okay, so our next step to find area. So we never learned how to find the area of a complex shape yet, but we have learned areas of some simple shapes. We've learned how to find the area of a rectangle, area of a square, area of a triangle, area of a parallelogram. Okay, we've learned lots of different ones. So what we're going to be doing is taking all those areas that we've learned before and applying it to this complex shape by dividing this complex shape into some of those simple figures. So this one here, we can see 2 ways to divide it into 2 smaller rectangles. The first is just to extend this line across here. Okay, so now we have this small rectangle up top and this this larger rectangle below. Okay, so we could find the 2 areas of those rectangles. Or alternately, if we wanted, we could divide the shape here. So now we have more of a square and a rectangle. And either way you do this, doesn't matter. You're going to end up with the same area overall of the complex shape. So let's start with this second way of division. So let's review something really quickly. The area of a rectangle, if you recall, is length times height. That's not it. That sounded wrong in my head. Length times width. The area of a square is the side squared. Okay, so let's use that information to find the areas here. All right, so let's look at our square first. What's the area of our square going to be? So let's plug in the length of that side. And we know the area of our square is going to be 16 square centimeters. All right, then let's find the area of our rectangle. So our rectangle is 3 by 6. So let's multiply those together, and we would get 18 square centimeters. So now to find the overall area of this complex shape, we'll simply add those two areas together. Okay, so the area of the complex shape as a whole would then be 34 square centimeters. Now I just want to show you something really quickly, that if we had decided to divide this complex shape up the other way, we would have gotten the same answer. So let's look at that. Let's divide it here. Okay, so now we'll do the area of this small rectangle. This small rectangle is 2 by 3, so the area is 6 square centimeters. Then this larger rectangle is 4 by 7, so it's 28 square centimeters. So add those two together, and you would once again get 34 square centimeters. So it's all about dividing the complex shapes up into familiar shapes that we already know how to find the area. So go with me then to page 558, and what we're going to do is look at the practice set. So because this practice set is pretty short, but also really new information, I'm going to set you guys off to work on that, and then in a moment I'll go over both of those problems instead of just giving you the answers. So pause this and work on that. Okay, so I hope you took the time to work on this practice set. We're going to look at letter A. So letter A gives us sort of like an L-shaped complex figure. Just going to draw a really rudimentary one here. And they also give us some dimensions, not all of them. So what the instructions for this problem said were to divide this shape up into two different regions and find the area of both. So first let's talk about the two different ways we could divide this shape up. Okay, so here's the first way. We can make two rectangles this way. Your second option is to divide the shape up here and to make two rectangles that way. So you're supposed to find the area both ways, but remember, regardless of which way you chose, you should get the same area. So let's just stick with this one here. So one thing that you'll see is that we won't be able to find the area of this smaller rectangle because we're missing the length of this right side. So let's determine what that's going to be. So we know the length of that right side plus 3 inches would equal this longer side 8 inches. So I can determine that this is going to be 5 inches long. So the area of this rectangle is going to be 20 square inches. The area of this upper rectangle, we have both of those lengths measured. So we have it 10 by 3. So the area is going to be 30 square inches. And remember, to find the overall area of the complex figure, we will add those two together. So we have 50 square inches. Okay, great. Letter B is a trapezoid, and it's sort of strange looking, but the instructions do give you a lot of help here because they tell you that you can divide this trapezoid into a rectangle and a triangle. So they were nice enough to give us that hint. So here's this trapezoid, and we're just going to divide it right here to make a triangle and a rectangle. Let's fill out what we know. We know this whole length is 14, this upper length is 10, and this width here is 6. So if that width is 6, then the height of my rectangle will also be 6. And now we have to find this measure, the base of the triangle. So we know that base of the triangle plus 10 is going to be 14, that overall length. So that base is going to be 4. And just to recap, we're going to do the area of a rectangle, length times width, and we're going to do the area of a triangle. So remember, that is 1/2 base times height. So let's fill out that information and find our two areas. So let's look at our rectangle. We've got 6 by 10. So it's going to be 60 square centimeters. Then for our triangle, The base is 4, the height is 6. So 1/2 4 times 6 is going to be 12 square centimeters. So add those two up, and together we have 72 square centimeters. So that's the area of that trapezoid, which, hey, you probably thought you didn't know how to find the area of a trapezoid, but now you do. Okay, so great job on that lesson. You'll find the homework in the description box of this video. You'll find it back in Google Classroom, and you'll also find it on GradeLink. All right, so please be sure to work on that. Let me know if you have any questions. All right, thanks, guys.